Hello everyone and welcome to this week's webinar. So this week we're joined by Todd, who is going to be talking us through some of the mathematical functions that Excel has to offer. So that should be interesting. I will just say, if you've got any questions throughout this live class, if you just want to comment them in the questions box, and I'll read them out to Todd when they come up. So yeah, over to Todd.
Thanks, Sydney. Hey everybody, it's good to be with you again. So today they've asked me to talk a little bit about mathematical functions in Excel, and there are quite a few of them. So I've picked out about 8 here that I thought would be interesting to cover. And some of these are really basic, and some of these you may already have some familiarity with. So it may be a little bit of a review. But I hope to get, and I think we'll have plenty of time to get down to a couple of my favorite that I've used pretty regularly in my own career, and have some pretty good business application, well, application in general, but especially business, and that's subtotal and sum product. And you might not think of these as mathematical in the general sense, like the sum, product, quotient. Those are almost more sort of a remedial or parochial, I guess, might be the word, like, you know, maybe sitting in school growing up, learning how to do math, how to add numbers and count numbers and multiply and divide and things like that. But we will get to these, the subtotal and sum product, and they actually do integrate these mathematical operations in a really fascinating way. So in very, very useful way. So without further ado, let's just go on to sum and take a look at that. And so sum does exactly what you would think it does. You could easily go in here and you could go in and type in equals. Most of you should know that by now to start a formula. So we'll type in equals and say you wanted to add a couple of numbers, maybe 5 plus 5, and you can do something as simple as this. So you get the result of 10. Or you might, do, maybe 400 plus 25, 425. So you could easily do the same with those numbers now that you have numbers in cells, where you would type in equals, and then you would refer to the cell reference, type a plus, and then if you wanted to add that to the number in cell C23 or 425, you could refer to that cell and then hit enter, and you get the sum of those. But with sum, we can type in equals, and then we start typing SU, and you'll see in the list here of available built-in functions in Excel, sum is down here about 3 down. And once you highlight on that, you can actually hit tab without completing typing the function sum. And then notice here, we've got our arguments, a little help here showing that you put in one number at a time. Now I could put in 10, and then I could type a comma and do 425. And then close my parentheses, hit enter, and then I get the same result. So you can see here in our formula bar, we've got C22 plus C23 gives us the same result as if we did sum using the literal values. But we can also do what we did, instead of using the literal values, we can actually refer to the cell references as well. So I can refer to C22 where our value of 10 is, type a comma, and then go over to C23, close those parentheses, and then you can see we get the same result. Even better, what's great about the sum function is that you don't have to type one value, one number, or single cell references at a time. You can actually use a range. And so if I type equals and do this again, I forgot to go down 3. But once the parentheses is open, I can go to my cell reference again, but then I can, if I go to that cell reference C22 and press shift and down, it'll now include that other cell, but you can see here now it's a range. So it's got the colon in between the two. And for 2 cells, that's kind of, just kind of pointless. What's the difference between a colon and a comma? But if you had multiple cells, that's where you get into the value there. So you can see you're getting the same result by 4 different methods here. So let's move up here. So I've got an example here where I've got a table with quantity, items. Let's say we went to the grocery store or the market and picked up some items, and I had to pick up this, quantity of each. So eight cans of soup at this price. I can do a sum like we did in the first place, where it's one number plus the next, plus the next, plus the next. But now you start to see how impractical that becomes. It's easy to do, but I still get the result I'm looking for. And so over in this column, we basically have my formulas that I've used to get these results here. And so here we've done it the most basic and probably most inefficient way. So I've taken all these cells one by one and put a plus in between those, and I get the same, I get this value of 19. So that's my total. And we can validate that by, if we highlight this entire range with those numbers. If you go down here in the bottom right corner, you can see here there's a sum of 19, so that definitely validates that. The one thing that you need to remember about the sum function is that it only adds number values. So even though I can do the same thing in this column, because these aren't number values, I'm going to get this value error. So I just wanted to point that out. The same with our dollar amounts or our financial or money data here. We can validate that that is definitely a sum of 15, 15. And again, we've used the same method. So if I pop down here, what I've done is I've gone to that range method. So I've kind of gone from the most inefficient method to the most efficient method. And again, that just uses the range. So if I double click in here, I can get into the formula, and you can see the highlighted range B5 to B9. So you can see right there, just with that simple example, how much more efficient it can be to use the sum. And we've done the same thing here using a range. So the other thing to note about using the sum function is that you can actually you can select cells that are within that range instead of the entire range, and they don't have to be next to each other. So if I double click here, you can see how we've selected just a couple, like for soup and for juice, we've selected the quantities there to get the sum of the quantities for just those. And then the same is true if you want to use a range and single cells, you can also do that. So if I double click here, you can see that we've selected this range from B5 to B7, and then included B9 in that just to exclude this one line here, or this one row. So there's different ways about it. You can use ranges with individual cells. You can use multiple cells like we've done here on this row, and so on. So it's pretty simple. So I'll go ahead and move on to count. Count is a little bit similar to sum in the syntax, so you don't have to learn anything new there. I won't go back to counting by cell, but you can do that just like we've done here, like in the sum example. We've used a range, but what count does is it counts the number of number values. So what we're getting here is a count of the number of cells that contain a number value. So again, similar to using the sum function, it doesn't work with non-number values. So we're not getting a result. We're getting a 0 here for count because it doesn't see any number values in this item column. So what we've done here is basically counted, and you can see down here that validates with our count of 5, and that's what's going on there. Again, even with our price amounts, it's just counting the number of cells with a price or some sort of number value in the cell. And again, we can select certain cells and exclude others in our formula by using a range and then single cells. So you see what we've done here is we've selected a range of 2 and then a cell, a single cell, and since all of those contain a number, we're going to get the result of 3 there. And so yeah, so with count, that's kind of valuable, and we'll kind of we'll see that used. It's valuable because from a mathematical standpoint, because maybe you want to do some sort of average or division with the count versus the sum of your total numbers. So let's move on. The next one we want to look at is product, and so this is multiplication. So using the same example, let's say we wanted to get the subtotal for each line item here. So for soup, we've got a quantity of 8. And so we want to get the subtotal of 8 times the price of each individual item. And so our first method here, we could definitely use just simple multiplication in Excel, which is just using the equal sign to start a formula, and then you select the cell reference, and then the asterisk is what you use to multiply by another cell or cell reference or another number. So it's as simple as we can do it with literal values like 8 with the asterisk times 109. And then that gives us 872. And then but we can also do here like what we've done is with the cell references. But with the product method, you can start typing PRO, and then it's the second one down here. We'll hit tab, and then notice the syntax is very similar to sum in that you select the numbers however many you want to multiply by each other. And so here it's as simple as, like, again, I'll use the literal value for the soup line, and that's going to be a quantity of 8 times the price of 109, and then we've got our result here. Here in this column, we've used cell references. Obviously, that's much more efficient in this situation. But we could also, it's not a very practical example, but you can use multiple numbers just to show you how that works. It's pretty simple. We can multiply all these prices times each other, or by each other, sorry. Then we get our result. I believe, I don't use product that much, but I believe we can, I'm not sure. Yeah, we can do the same thing. So you can still use range just like you can with sum if you want to multiply several numbers, and then we can even try this out where we might use, actually, let's just do this just to make it interesting. And so there you go. So it's very similar to the sum function in the syntax and the ways, different ways you can use it. You can use ranges in order to be more efficient when you're using multiple values, and then if you need to skip some, you can use contiguous ranges with single cells or single cell references, and multiply numbers that way. So pretty simple, straightforward. I mean, it's just simple math. I think, so we can do, I was going to use an example here to kind of lead up to using some product a little bit later on in the webinar. So I'm trying to think, how would I do this? So we've got equals. So yeah, so that's how we get, so we've got a total for our bills here. So we've got, each one of these items is basically subtotaled here because we're multiplying our quantity times our price. And so this is our subtotal for that line. It's 872 for 8 cans of soup, $11.98 for 2 pizzas, $10.47 for 3 bottles of juice, and so on. And then this is our total. So if we were to, go pay for our stuff at the register, then this would be our subtotal before tax and whatever extra we pay. And so that's one way of getting a subtotal. But so you can use the product function to get all your subtotals, and then you just sum those that entire range of totals, and that's one way of getting a subtotal. But I'm going to show you is just keep that in mind as one method, and then when we get to sum products here in a little bit, we'll see how it's real easy to get a subtotal like that without actually doing these separate calculations per line. So With that said, we'll move on to quotient here, and that's simply a method for division. So let's say we have our subtotal for all of our lines. We have the price, but we don't have the quantity. We don't know the quantity, so we need to know, okay, so what's the quantity for this line, knowing that our subtotal is this number and we know the individual price. So we can get our quantity by just doing simple division, which in this case, I've just used cell references, but it's the same as if I wanted to take my subtotal and divide it. I'm sorry, I meant to do that in literal values, not be redundant. And so 872 is our subtotal, and we'll divide that by 109. And of course, we get our quantity. So there it is in literal values. What we've done here is just use cell references. As you can see, D5 here divided by C5, and they're color coded there for you. And then, so that's one way of doing division and getting your results that way. So there is a, much like the sum function, the product function, there is a function called quotient. So we could actually start typing out quotient and then tab, and then we'll take our subtotal and we'll place a comma and then our price, and then that also gives us our quantity. So you know, this is a very simple example. You know, it's going to be different preferences, and really the usefulness, and like I showed you with the product and sum, the real usefulness is when your calculations tend to get a little more complicated than just this very simple example. So you can see here where, you know, that might be easy enough just to use the sort of manual process of dividing, but you can do it this way. And then if you're, say for instance, you want to maybe, we can do this. So for instance, we can do quotient, and then maybe we want a sum of our subtotal, and then we can place that there, and then you can still see here, now I put a comma, the next term or argument is going to be my denominator. Now that can either be a number, a literal value, it can be a cell reference, or it could be another function. So let's just, for the sake of demonstration, do sum of all of our prices, and then we'll make sure we need to close our parentheses. Here we had two sets of parentheses because of these inner functions, and then we get this value of 2. So that's just, not that that's a practical example in any kind of reality, but I just wanted to show you that even though this looks really, really simple, it is simple, and that's the elegance of it. You can now use other functions as your arguments, much like we've done in some of the other webinars. So that's where the real value using the quotient or the product, sum, and even count functions is that you can use functions within those, building those formulas as your arguments. So I hope that kind of gets you to thinking about how this can be useful in a more practical sense, because obviously in this simple example, this is much more efficient to write this formula rather than even beginning to type quotient out. So anyway, so the next example we want to look at is average. And so this can be really practical. It's simple, but certainly very practical. You could look at, for instance, what's your average price of all of your items. And with average, it is the full word average. It's not AVG. And so now that I've found that, I'll hit tab. And then again, it's just like the other mathematical functions we've been looking at, the same syntax. So it's number 1, comma number 2, and so on. But since we've already kind of covered that, I'll just select this entire range. And then you can kind of see your average price for all of these items. Just a straight average is 303. And so Here we've done that. You could do it. You can do your average the long way, like I was talking about before, using the count function as your denominator. You're counting the number of numbers, remember, which is 5, and then the sum of that same range is 15, 15, so divided by 5, that's going to give us a value of 303, and we've gotten our average that way. But if you use the average function, it's dramatically less complicated, less complex, and a little more efficient to use the average function. And again, you can use literal values. I know I'm using these cell reference examples because this is kind of the way I use it most of the time. But we can use literal values, and it can be multiple terms, that kind of thing. And then there you have your average. So with average, it really simplifies things because you don't have to worry about numerator and denominator in your average, whereas we've done that here. So it definitely is a far more efficient method than this longer method here. So the next thing I wanted to show you and wanted to talk about is the absolute value function. And this is, I don't use this a ton, but I do come across the need for it. And I tried to think of a good example of something I'd done in the past. I really couldn't dig anything out of my brain. But here's an example. We'll just kind of stick with the same concept. We've been using these line items from a grocery bill. And so let's look at an example here where maybe we're comparing prices to, maybe we bought a bunch of items here that were on sale. And so we're comparing to the regular price to see how much money we saved. And perhaps we bought an item that we don't normally buy because maybe our dog has just decided to get finicky and doesn't like the old dog food that we were feeding it. And so we've gone to another brand and it's a little bit more. And so we see we've got an increase in our price here. If we needed to just get a value for that rather than showing the negative here, it's in basically that's in currency form. I think it should be currency. Well, so there's a negative. This is an accounting form. But say you have negatives. If you use the absolute function, it'll give you the absolute value. So any negative values become positive values. And so maybe, I'm trying to think of a good practical way to approach this, but this is the best example I can come up with. But it is actually very valuable because I know I've used this in the past. And so a lot of times when you have negative numbers, depending on maybe another function you're using, it just doesn't work well. The absolute value can be extremely practical, extremely useful to turn that into a positive value. So all it is ABS and then the number. So you can either, again, it's, negative literal value becomes a positive number. Not that needs to be $1, but a dollar amount, but you see what I mean. And so it's the same thing here. We've taken that any negative values in this column can become a positive value here just by using the absolute. It's a real simple function, but it has some mathematical application in the sense that it can turn negative values into positives very easy. So I don't know, Sydney, are you getting any questions? I'm sure you would have told me if you had, but I was going to jump into subtotal and some product here, but I'm ripping through these a little faster than I thought I would, so I thought I'd check in before I did that.
Nope, we haven't got any questions.
Okay, very good.
So carry on.
All right. Very good. So, all right, so let's jump into looking at subtotal. So the subtotal is, this gets a little more complex, but the subtotal function is a really cool function because it has a lot of different applications. because it offers a lot of choices as far as what you and how you want to subtotal your values. So the syntax is basically subtotal is your function name, but then you have this function number, and I'll show you that here in just a second, and then your references. So the function number is, once you type in your subtotal function, it'll return a subtotal based on a list, but once we hit our tab here, it gives us this whole list of function numbers, 1, 2, 3, and so on. There's a lot of them here, but we'll basically stay kind of in this range here, this 1 through 9, I guess. Yeah, so when you select these function numbers, it's going to apply to a specific operation. So like for instance, 1 would be average. So you can type in a 1 as your function number. And now what I'm going to do is, if I have you know, a set of values within a range, it's going to average those. But if I go back to the same formula, I can change my function number to a different function. So in this case, it would be count. Or did I do count or count A? Yeah, so count. And so in this case, D3 through D8, that's 6 cells with numbers in it. We're going to get the value of 6, or the result of 6. But fascinatingly enough, if I go back to 1, I get an average for those. So you can use the same formula here, or same function, and just change your function numbers to get what you want. So say I wanted to get, you know, the product. So I would just go in and type 6 and be done with it. And then I think there's, let's see, did we go to, so that 9 is sum. So this is another alternative to using like the sum function, the average function, the product function, especially if you're using a list or a range of values. This is where it really comes in handy. So let's look here. So down here, I've got total count of scores. So what I've done is I've used the subtotal, and my my range here is the total number of students. So on each line here, we have total number of students that scored a particular score on a test. And so we've got our letter grades here too, and we'll use that. That'll be relevant here in just a second. So we've got total number of students. Now I could have done sum very easily, or I'm sorry, count. Forgot what I was doing. So I can do a count, and that's going to give me a total number of scores, not total number of students. That's next. So I could have used any of these ranges. Since we're doing count, I could have used this, and I get 14. If I go back and I can move this again, 14 is the total count of scores. But I'm using subtotal. Now I could have easily used count, right? And get the same result. So just kind of a cool contrast there. But the cool thing about subtotal is that you can use basically the same formula and just adjust your function number. And we've done that here. So we've got, for total number of students, I've used basically, it's the same function. It's the same formula. All I had to do is change my function number to 9. And done that for the sum, and so I get the total number of students in this range here. So we get the total count of scores. Again, it's the same thing. We just used a different range. We've used this range in column D. I think we already covered that, how I could have moved this around. So you get those two numbers agree because they're basically counting the same thing, because both of these ranges have numbers. And then your aggregate total score. So we can use subtotal with the function number of 9, which we know is the sum from using it over here for total number of students. And then we get a total aggregate score, which we can validate that by highlighting that entire range. And down here we have the sum, 1167. And then same function, but now I'm going to use the function number of 1, which is our average. And so the great thing about this is once you have what you need, like in this situation, I have several different data points I wanted to create, or several different metrics, if you will. And I've just basically started by using the subtotal formula here, and then I've locked my range D3 to D16. And just as a review on that, some of you may or may not already know this, I can just back up here, and then let me highlight this range. And then once it's highlighted, I can press F4, and it locks that range in. So what happens is with those dollar signs, now it means the column and the row references are locked in place. So when I drag this down, which I'll do here, it stays the same. So this range is D3, D16, no matter how far I drag it down. If I didn't do that, it would become like D4 to D17, D5 to D18, and so on. And so, oh, well, now I've got nothing but count in all of these. Well, all I have to do is go to this function number, and again, this aggregate total score is the sum, so I'll just choose 9, hit enter, and we're good to go. And then we want the average score, so I believe that's function number 1. So we'll type a 1, replace that 9 with a 1, and now I have average for these scores for that range. And there's also a choice for max. There's a function number for max. So if I wanted the maximum score, which obviously just because these are all in sequential order, it's easy to see that just by looking at it. But if those weren't all in order, they weren't sorted, this would be a great way to quickly find the maximum score. And again, for this, we can do minimum score just the same by just changing that function number. So it's a really cool function and mathematical function, but it can be adjusted and adapted to whatever your need is. And just to kind of see, there's count, there's obviously max and min we've used, product, standard deviation. I'm not a statistician, so I don't use these, so I'm not even sure what the S and P mean. The sum, and again, probably some statistical function numbers. So for those of you that are, in the statistics and you use that, this is something that might be worth exploring for you. But it's a great, and in fact, probably very underused function in Excel, and I'll even admit in my own career, probably way underused. But just to kind of give you a little bit of a rundown of that, that can be extremely useful, and it just builds on what we already talked about with these simple sum, product, quotient functions. You can do the same with subtotal, especially when you've got a list or a range of cells. And again, the great thing about it is you can kind of easily type it in once, and like we've done here, fill it down if you've got several different results that you need, and just change your function number. So I hope you find some value in that. Now we can look over here at sum product, and this is a really cool mathematical function depending on your application, and I've tried to come up with a couple of different examples to kind of show you how powerful it can be.
Hi Todd, sorry, you've got a question?
Sure. Okay.
Olive just said, could you please explain the absolute reference again?
Absolute, yeah. So I'm assuming we're talking about this function here, ABS. This is a way for you just to quickly turn your values into an absolute value. So what that really means is that any negative values become a positive in the sense that, so, you know, we have in this example, we paid more for dog food than we have in the past. So we didn't save any money. So it's negative savings or an increase in our spending. And it was in the amount of $1.20. So it's a negative value. And if we just want to know what's the magnitude, rather than having that negative value, we just say, well, the magnitude of that was $1.20. So there may be situations where you need to just know the magnitude of a value, a number value. You don't need to know negatives or positive. The absolute function, all it is, and it's really, really simple. The syntax is simply ABS is your function, and then you just place a number. So let me just go, like in this situation where I put a -1 in, if you place that number in with the absolute function, it becomes a +1. Any negative value using the absolute function just becomes a positive. So it becomes a value of magnitude rather than negative or positive. Well, I mean, it's positive, but I hope that explains that. So if that's, please let Sydney know if that doesn't clarify it. If I didn't understand that question correctly, I can definitely stop what I'm doing and kind of go back and expand on that if I need to. But short of that, I'll go back over here to sum product. And so sum product is an interesting function that I find really fascinating. And I learned how to use the sum product in a job role several years ago that actually for some of my colleagues was actually very eye-opening. They were very experienced analyst Excel users. So what sum product does is, just to look at the syntax here real quick, is it takes multiple arrays that end up, what they do is they multiply, they're multiplied by each other, and then that value is summed together. And so the one thing to be cautious about when you're using sum product is to make sure that your arrays match in dimension. And what that means is if you have, these arrays can be either vertical or horizontal. So they could be a column of values like we've been using, like in this worksheet here you see, like for instance our quantities are from cell B3 to B7, so that's a vertical array, and it's what I mean by dimension is the number of rows that vertical array is from B3 to B7. So in order for us to use another, what we'll do here is I'm going to show you an example that takes the quantities and matches those to the price and does a sum product. So that would have to be cell B3 to B7 for my first array. And then my second array is going to be D3 to D7. Those are the same dimension because they're going from this, they're starting at the same row. They don't even have to actually start at the same row, but they're the same number of rows, I guess is what I should say. So from B3 to B7, you're going to have 5 rows for that array. Any other array that goes in that sum product has to be 5 rows or it won't work and you'll get an error. So I can actually show you an example here. So let me select the quantities, and then I'll select, say for instance, maybe just by accident I don't select D3 and I start at D4. If I close these parentheses, I'm going to get this value error, and that's because it doesn't have these two arrays don't have the same number of dimensions. Now, if I fix that, it will now make the calculation for me. So just to give you some kind of prelude to what we're doing here, just to know, be careful with the syntax, or be careful with your range dimensions. So in this case, again, let me just go ahead and type in some product. When I get to SUMP, it's the only remaining showing here in the list, so I can go ahead and hit tab, so you save yourself some time. You don't have to type the whole thing out. And then again, use my arrow keys, and I'll go over here to B7, and then shift up to get to, and here you can see your row reference, your column reference, so you know that's 5 rows. And then type my comma, and then with my up arrow, go up to D7, and then let's set that up just like we did. And so what this is doing is, in one formula, it's basically doing the same thing as what I did over here. Where were we with that? So remember here on the product tab, where we were looking at using products, using the product function, we multiplied the quantity by price per line. And so 8 times 109, 872, and then we did a sum of that entire column to get our total. Well, contrast that with what we just did in a single function here with sum product, and you don't have all those other calculations. So it's really, really cool. Even with a simple example like that, it's a really cool function that allows you to do basically 2 mathematical functions within one formula. So let's look at another example to kind of get you thinking a little more, maybe a little more complex about using sum product. So let's go back to our grade list here, our scores. So we could say, okay, we've got all these different scores, right? So we've got these single scores, just give me an average. Well, if you do a straight average, like we've used the average formula here, or average function, and then with that entire range of scores, we get a straight average of 83. Well, that doesn't really tell the true story about what's going on here with our scores, because you've got different numbers of students scoring those particular scores. So here you see that you've got 2 students that scored 100, but you've got 5 students that scored an 89. So it's really, this 83 average is not telling the story. It's just telling you the average of all these scores as a single instance. So one thing you can do is you can do a weighted average to kind of get a real feel for what are the real scores, what's the real average for your entire class based on the number of students that are scoring a particular score. So we use a weighted average, and it's really easy to do that using the sum product. But there's another way of doing it. Say you wanted to do it the long way, you could easily take, and what I've done here for the percent, I've basically taken the number of students in G3 for each row. I've taken like G3 divided by the sum of this entire number of students. So the entire number is 32. So this is going to be 2 divided by 32. That's 6% of the total number of students, and that 6% of the total number of students scored 100. So I can actually take that percent and multiply it by the score, and I can get a weighted score here. And then I could sum all of those and get a weighted average score. Well, that's a lot of steps to do that, and it definitely works, and it's definitely practical, and it definitely maybe not even take that long if you're used to using these functions. It may only take you a couple of minutes. However, with sum product, you can do this with one function and be done with it. So you can just type in sum product like we did over here with our grocery items, and then our 2 arrays are going to be the percent of the total and then our scores. And so you're going to get a weighted average of the scores in your class, which is actually higher than just a straight average of the scores. So you get a better feel of what's the real average score for your class, and the real feel for the score level for the entire class in aggregate is 85, which, 2 points higher than just the straight average. So if we wanted to, I'm going to another example. This is really cool. So I just kind of try to take it a step further. And this is, there's actually, I've never done this before, but I was just kind of doing some research on some more interesting examples just to show you the power of some of these mathematical functions. And so I found this, you can actually use some product where the general syntax is just array, multiple arrays. So in our situation here, it's pretty simple, just 2 arrays, % times the score, and then the sum of those. You can actually use some product a little bit more complex. And so what we've got here is we've got some product, and it takes our number of students, and for our first array, it's the number of students in that array multiplied by the score, and then an asterisk to multiply that by this array here, which is our letter grades, and then whatever that equals, any of those letters. And what I've done is place that in here in cell reference M8. So for all of the B's, we're going to isolate that, and we're going to divide that by, and this is just an example. I don't expect everybody to absorb all this. It's actually very, almost kind of obtuse to me, but I found it, and I thought this is a great example of how powerful this can be if you do some further research. Basically, this sum if here says that if within this array, if I want to isolate it for the value in M8, which is the B's, so it's just going to be these 2 items here, and then sum the number of those students. So basically what it's doing is it's finding a letter grade average based on the letter grade we find here. So this changes accordingly just because I'm using this cell reference. And so it's just a cool way. I don't expect you to learn that because that's actually kind of complicated for me. I would have to actually go back and think about this. But it's just showing you how cool building on these mathematical functions kind of along the way, cumulatively, you start to get the concept and how they kind of all come together with these more complex functions like sum total and sum product. And just to show you one more little example, I used to use sum product in like I was telling you, in a job role a few years back. And say, for instance, you wanted to, we used to analyze pricing proposals from vendors for groups of hospitals. And I don't want to get too complicated with the story, but I was trying to give you some context. So we would basically take a pricing proposal from, say, vendor A, vendor B, but they would make it real difficult. So they would make, price transparency is not at the top of their list of priorities. In fact, they go to extraordinary lengths to make it very, very difficult for you to get a real feel for what the pricing is for their products. So what we would do is they would send us a proposal, and they would give us different price points. And you might compare it to, like, if you were to go to the store and you were to buy maybe a single bottle of soda or something. You're going to get a better price most often if you buy, say, a case of sodas per unit. So it was very similar here that they would give us better pricing in multiple quantities. So maybe you have vendor A, they, if you spend, X number of dollars, or basically their base price might be $10 per unit. Or if you spent over the previous year, over an annualized basis, you spent over $75,000 with them, you would get a price point of $9 per unit. And then maybe they would give you a better price of $8 a unit if you spent over $100,000. But then vendor B might make it even more complicated by giving us 4 different pricing tiers, and they would have their different requirements. The whole point is we had no way of knowing. It was extraordinarily difficult to compare or get it down to an apples to apples comparison. because they made it so difficult. So how are you going to compare one vendor who has three separate pricing tiers to another vendor that has four separate pricing tiers? You can't just do a straight average. If you do that, you can see here vendor A, their average price, just a straight average, is $9 a unit. Well, you know, vendor B, if their straight average is $8.75, you're just going to say, okay, well, vendor A or vendor B has the best pricing, so we'll just walk away from the negotiations and we'll award vendor B with the contract because they have the better price. But that's not the case, because you have to go back and do the analysis. How many members in your group spend over $75,000 a year, or over $100,000 a year? Well, vendor B makes it even more difficult, because they're saying, okay, well, we'll give you a pricing tier for those that spend over $25,000 but less than $75,000, whereas vendor A didn't do so. So you've got a different set of percentages here, and I just put these in here. I try to make it as reasonably realistic as possible, but all of these add up to 100% in spend. Well, you have to do a weighted average, and so I can use some product to do a weighted average of each of these price points. So I might find that 25% of my group spends less than $75,000 a year. So they're going to get, it's going to cost them $10 a unit. Well, I know that 40% of my group spends over $75,000 but less than $100,000. Well, they're going to get $9, and so on. So you know where I'm going with that. So I do a weighted average. Vendor A's price is actually at the each level more close to $8.90 rather than $9, where we thought it was $9. Well, the same thing for vendor B. I'm going to do some product because I know the percentage of my group that's spending X number of dollars on an annualized basis, and based on their pricing proposal, I'm going to do a sum product to find out what's my actual weighted average. And we find out that vendor B, on a weighted average basis, is actually costing us $9 a unit, and vendor B, whereas with the straight average we thought might have the best price, they don't have the best price. Vendor A actually has the best price. So that's a real kind of close to my heart example of how to use some product and give you kind of the quick or quick answer to what your needs are. Now, I could have done this just like we did with back here on product, and I could have done this line by line, but it's far more efficient just to use my sum product. But that's a good example of where sum product is extremely useful, is when you're using weighted averages, because it can tend to tell you a little bit more about your data, especially when you're doing mathematical stuff. So I know I went pretty fast through that, and if for those of you that have never been in that kind of business, it may have gone over your head, and that's okay. I hope somebody got something out of it, but I think obviously sum product and subtotal are a couple of the really coolest mathematical functions that Excel offers, but they all build off the simpler mathematical functions, which also have their uses. And one more thing, I just thought about it. I wanted to show you on using sum. I don't know how many of you know this, but you can use, let me take an example here. I'm going to copy and paste this just to use this. So there is a way you can use what's called auto sum. And so if you have a contiguous array, a range of data, number
someone
data.
put in a question, Todd.
Okay, sure.
Alexandra said, on the sum product tab, example 4, how did you enable the drop-down selection to choose which grade you apply the formula to?
Oh, so we were asking about this. I basically, this is kind of outside the scope of the webinar, but it's real easy. So I have a hidden, I think this is what the question is, but I have a hidden range here where I've taken all the duplicates out of all the letter grades. And basically you just go to a cell that you want to put that drop down in, and you go to the data tab. I'm going to go real fast because I know we're running short on time. So I'm in Excel 2016, but I believe it's still very similar, if not the same, in Excel 2013, 2010. I'm not sure before that. But on the data tab, with your cell highlighted where you want the drop down, you go to data validation, and click on this drop down, and then select data validation. This data validation dialog comes up, and on the settings tab, just select out of this selection, select list, and I keep these boxes checked because I want it to ignore blanks and I want it to be an in-cell drop down. Here you just basically select your range, your source, and so I can clear that out, and so I basically go over here to my letter grade range, and I just select all the cells in that range I want to show up in the drop down box, and basically that's it. You just click OK, and then you're there. And then basically the reason why I did that is just to make it easy. I could have typed those in one at a time, but I do that for the sake of speeding up the demonstration. So yeah, it's one of those things that I use all the time. And I hope that answers the question. I think I understood that correctly. That's how you do that. But if I can go back real quick to this sum page, I was going to, I believe it's alt equals, yeah. So if you either under a range, or if this were a horizontal range at the end of it, if I go down to the cell just below that, if I press alt equals, it automatically places that sum in that cell with that range. It's real fast. It's called auto sum, and that's a real simple way to do the sum. So that's all. You don't have to type in sum in the range or anything. So it's alt equals, and there you have it. So yeah, so that's basically it. I'm sure there's more questions, but I don't know if anybody's typing those in. But I hope some of you maybe have seen the sum product and the subtotal for the first time, have discovered something new that you can go back and practice with and find some value and find where you can use that in your work or your career.
Okay, so
yeah.
I hope everyone enjoyed that. I hope everyone learnt something, took something from that. Someone just Mark put, what was the equation on H3 in sum product?
Let's see. In which one? In here? What do you say that? Repeat that.
What was the equation in H3 in sum product? So H3.
Oh.
The equation.
Oh, he's talking about the percent of total. So basically all that is, so I've got this number of students column that shows like there's 2 students that scored 100. So you're basically dividing the number of students by the total number of students. So that's G3, which is 2, the value 2, and then I summed G3 through G16, which is the total number of students. So it's basically 2 divided by the sum of 32. So this ends up basically in literal values becomes 2 divided by 32, whereas on this row it would be 3 divided by 32, 4 divided by 32, 1 divided by 32, and so on. It becomes a percent, and you just want to set your what do you call it? I'm sorry, I'm like your formatting for your percent column there to percent to give you the percent. Otherwise, if it's a number, you get that decimal. So I hope that answers the question.
I think it does. So yeah, we're just about out of time now. As I said, I hope everyone enjoyed. As for this recording, it's being recorded right now in this webinar, so within the next, it's bank holiday here, so by tomorrow I will have this emailed out to everyone, so you can watch it whenever you want to. So yeah, that's it. Thank you, Todd, for that.
No, thank you.
I hope
I enjoyed it.
Everyone enjoyed.